Hello everyone, I'm Weedy from Group 4. So today I would like to share with you guys the backpropagation mechanism of ANN. So this is the simple ANN model which is provided by Doctor in e-learning. So you need to know that this model is a multi-layer perceptron because it consists of one input layer, one hidden layer, and one output layer. How to do the backpropagation mechanism? The first thing you need to do is just assign a value for each node. So you can see here, you just assign number 1, 2, 3 for the input layer, 4, 5, 6, 7 in the hidden layer, and number 8 in the output layer. So each node have their respective value already, right? Then you need to assign the weight for each error. For each error, how you want to assign the value is just very simple. You see where the error is pointing from and pointing to. So if you want to assign the value for this orange, the first orange error here, you just need to know that it's from first node to node number 4. So the value will be W14. And for the green color is from node 2 to node 4 will become W24. So all the weight is assigned to each error, and then you can start to do the forward pass. So before we go into the detail of the forward pass of the ANN, we need to know that the node in the hidden layer and the output layer is divided into two parts, which is the input function and also the activation function. So now here, to get the input function, we call it as net. It's just a summation and multiplication of the weight and also the input. So for example here, W1 times with X1 plus W2 times with X2 and bias times with 1, you can get the equation net is equal to W1 X1 plus W2 X2 plus B. So you can use the net and as the input of the activation function. The activation function can be sigmoid function and the unit step function and other softmax function algorithm to test that whether this input will trigger the output or not. So if they have an output, you can see the output as O here. So now let's look at the forward pass of this simple ANN model. First, we go to the hidden layer. To find the input function of the node 4 is very simple. It's just the multiplication of input and also the weight of the error. So by multiply the x1 with W14, x2 with W24, and x3 with W34, and summation of it, you can get the net number 4, the input function of node number 4. And to get the output of the node number 4 is very simple also. You just input the activation function and put the net into the center of it, and you can get the output of 4. So to find the output layer, the algorithm for node number 8 is very simple also. It's just the multiply with the O4 with the W48 plus O5 with W58, O6 with W68, and O7 with W78. And you can get the net of node number 8, and also the output is just the input of the input function into the activation function. You can get O number 8. So now I want to bring you guys to go through the backward pass of the simple ANN. So we go to the output layer first. So we want to know how much change in W4 affect the total error, which is dE over dW4 or which is known as the delta W48. So the W48 is around here, which is belong to the output layer of the ANN model, and you can get the dE over dW48 by using the chain rule. It's a multiplication of dE over d bar times d bar over d net x times d net x over dW48. So the original equation is here. So after you doing the differential equation of this original equation, you can get the minus y over y bar. I assign this value as the E8. Later, this value will be used in the general step of the backward pass. So the O8 is equal to F net 8. And I just do the differential equation for that. You will get a F prime net 8, and this equation and 8 net is equal to W4804 plus W5805 plus W6806 plus W7807. After differential equation of the DW48, you can only get all 4 because the value behind will be cancelled out. So all these three equations, you can just get from the forward pass. You can see here the output layer. I already show you guys how to get the equation. So after this, you just multiply with this all the value together, you can get this value. So after that, you just simplify this, become d delta 8 times with all 4. So the summarize of all the value for the output layer is just alpha, where the alpha is the learning rate, and the times with delta 8 times all 4, and all 5, all 6, all 7 for the each delta W. So I would like to bring you guys to go to the backward pass of the hidden layer. We want to know how much change in W14 affect the total error, which is dE over dW14, or known as the delta W14. So W14 is belong to here. To calculate the dE over dW14, we also use the chain rule, which is the multiplication of dE over dy bar times with dy bar over d net 8 times with d net 8 over dO4 times dO4 over d net 4 times d net 4 over dW14. So these three equations I already show you guys is you can get from the forward pass of the ANN model, and after you differential using the differential equation for it, and they will become all this value. And now the two more equation is added, which is O4 is equal to F net 4, and net 4 is equal to W14x1 plus W24x2 plus W34x3. These two equation is also get from the forward pass. So for the d net 4 over dW14, you only can get the x1 because the other two value will be cancelled out. So these two I already showed you just now. These two will be assigned with delta 8, which is I will mention as the 8 just now, and also the E4 here I will assign for delta x times W48. So the simplified equation will become the D4 times x1, because the E4 times F prime net 4 I will assign as D4. So the simplified equation for this hidden layer will be the dE over dW14 is equal to D4 times with x1. So all the same principle is applied for each nodes in the hidden layer, which is W1424, W34, W15, W25, W35, and apply to all the same. So after that, this is show the summary of the backward pass, and each of these have the output layer. I already showed you just now how to calculate, and also the hidden layer, the final equation of each node. So now I would like to bring you guys to go through the general step training and Just now, I assign each value with different number. For example, for input layer is 1, 2, 3. Then the hidden layer is start from 4, 5, 6, 7, and output layer is only 8. But now I will change it to another. I will assign a new value for it, and each layer the value is start from 1. So 1, 2, 3 for input layer is remain the same, but for the hidden layer it changed from 1, 2, 3 to 4, and for the output layer is only have number 1, and the weight of the weight of the error is changed also according to the number, and each of them I assign with the number 2 here. You can see here it shows the layer, because this one is belong to layer 2, and this one is belong to layer 3, and this one is belong to layer 1. So each of them is assigned with the value layer 2 and 3 for each weight. So this is the forward pass after generalized step. So you can see all the value already changed like I said just now, and if you want to find the original node 4 is now is net 1 in layer 2. So to get the value of it is the same principle is applied. But now the W11 at layer 2 is times with all 1 in layer 1 plus W21 in layer 2 is times with output 2 in layer number 1 plus W31 in layer 2 is times with output 3 in layer 1. So you can get the net 1 in layer 2, which is representing the net number 4. And the output of it is also the same. By activation function in bracket, we put the net 1 in layer number 2. So this one is the backward pass of the simple NN model after the general step training. So you can see the hidden layer and the output layer, the value, the respective value is replaced because all the new value is assigned to each error, and also the delta and the local error is assigned the new value too. So each of them is assigned with the new delta with respect to the original equation just now. So the W11 in layer 2 in here is representing the W14 at the example just now, and all the value is replaced with the D12 and also the output 1 in layer 1 to get this value. So all the principle is applied the same. Later you can just review on this slide for more detail. So just now in the backward function of the NN model, I says that the E8 is equal to minus in bracket y minus y bar, right? So after I simplify it, it becomes this equation. And for the delta 8 is also from the very complicated equation, I can make it the simplification of it and become D in layer 3 is equal to local error in layer number 3 times with F prime nets number 3, layer 3. So for the hidden layer, the local error of node 4, 5, 6, 7, and also the delta for 4, 5, 6, 7 is also apply the same things, and I simplify all the things, and the output of the equation is this. So now I would like to make a simple summary for the presentation I present at the beginning until now. So to train a simple NN, the first thing you need to do is initialize the weight and the bias with the value and set the number of layer. In this case, the layer is 3. So then after that, you need to enter the input from the training data X and Y and obtain the Y bar as a neural network output. So to calculate the local error of the output neuron and delta, the equation you need to use is here. I already say that I already summarized it, and this general equation is used in and implement in the output layer to calculate the output neuron and the delta. So after that, you use the propagation of the output neuron delta backward and calculate the delta of the hidden layer. So these two equation is coming from these two, and I generalize it, and the number in the layer here is replaced with k, where k is the total layer minus 1. Then you adjust the weight according to the following learning rule, where this rule is the gradient distance algorithm. So each of them will calculate the weight and update the new one, and going on for the training. And then to make the training more accurate, you need to train a few times, right? So you will repeat the step number 2 to 5 for every training data point, and repeat the step 2 to 6 until the neural network is properly trained. So this is all from me, and thank you for paying attention in my presentation. I hope you enjoy and understand my presentation. That's all from me. Thank you.